Welcome to Spring LIB.
In this question, given data is there is a first figure given, so I will draw this figure. So in this figure there is two semicircular body is given. So having first semicircular body having radius, that is r1, and now second semicircular body is this having radius, that is r2. So this figure is given, and now in the question it is saying that is we have to find the center of mass of uniform plate having semicircular inner and outer boundaries of radius r1 and r2. That means we have to find the center of mass of this uniform body, so whose radius, inner radius and outer radius is given, that is inner radius is r1 and outer radius is, that is r2. So now let's start answering this question. So in the answer here I will consider that that mass of plate will be, that is capital M. So here I am now considering a small semicircular portion of mass dm. So it will be written as, that is, and the radius of this semicircular portion is considered that is radius r. So you can see that here I am taking this mass dm, this thickness. Consider that in this thickness the mass is assumed at small dm. So now and consider that for this portion the radius is, which I assume that is small r. So my next step is, after taking this portion, is semicircular portion, I will try to find the dm, that is mass. So it will be written as, that is capital M multiplied by area of this semicircular portion. So it will be written as, that is pi r dr over now total area of this uniform body given, that is, so I can say that pi times of r2 square minus r1 square over 2. So now I had get the mass dm in this thickness, that is dr, small thickness. So after getting this dm, now I will write the equation center of mass in integral form. So here I will take the limits by taking this semicircular portion, and the limits are, that is r is equal to, small r is equal to r1 to small r is equal to r2. So I can say that the center of mass will be written as in the integral form, that is for only y coordinate will be written as, that is integral r1 to r2 y small y dm divided by capital M. Here y is a coordinate of center of this semicircular portion, so it will be written as, that is, we know that if there is a semicircular portion is given, then the center of this, the y coordinate of center will be written as, that is y is equal to 2r over pi. So I can say that here substitute this data, so it will be written as that is YCM is equal to R1 to R2, Y will be that is 2R over pi, and dm is which I had get in above step, that is dm is equal to this. So right here I can say that dm will be written as that is m, then m pi dr divided by pi times of, in the parenthesis I can say that r2 square minus r1 square divided by 2, and now write the remaining term in the formula, above formula. So here we have to write 1 over m which is remained. So now after substituting the value of y, dm, and putting the value of 1 over m in this formula, next step is take a constant value outside. So after taking outside, it will be written as that is y coordinate of center of mass will be written as that is ycm is equal to r1 to r2. Sorry, first write the constant value, so it will be written as that is, here you can see that here pi to pi cancel out. So after simplifying this constant value, it will be written as that is 2 over pi times of parenthesis of r2 square minus r1 square over 2 integral r1 to r2 small r square dr. So now next step is simplify it by taking a integration of r square dr in this term which is written on the right side. So I can say that it will be written as, after taking integration about r, so it will be written as that is y coordinate of center of mass, that is ycm will be equal to 2 over pi times of r2 square minus r1 square over 2, and now integration of r square dr about r means will be written as that is r cube over 3, sorry, small r cube over 3. So now next step, here write the limits, that is r1 to r2. So next step is, here we have to apply the limits in the bracket. So using the fundamental theorem of calculus, so it will be written as that is ycm is equal to 2 times of pi over r2 square minus r1 square divided by 2 times of, first apply the upper limit, then take a negative sign, then write the lower limit. So it will be written as in the bracket that is r2 cube over 2 minus r1 cube over 2. Now simplify it, then final value will be that is ycm is equal to that is 4 times of parenthesis of r2 square plus r1 r2 plus r2 square divided by 3 pi times of parenthesis of r1 plus r2. So I can say that this is the answer of given question. I had get the y coordinate of center of mass here, and also you understand that x coordinate of center of mass will be written as that is 0, because if I here consider that is center as origin of x coordinate, center of x, sorry, origin of 2D y coordinate, then I can say that the center is here lying of this uniform body will lie on this y axis. So you can notice, you can understand that only ycm will be found, we can calculate xm is already automatically 0, that means x coordinate is 0. So I can say that this is the answer of given question. Hence I had solved the question completely. Thank you.